So during our system here, we're going to be checking for interlocks and permissives. We check for our interlocks the entire time, and then we look at our permissives only during the beginning. So a few things. This system is probably not going to have any interlocks for it during this time. We're going to handle all the transitions for the alarming. But let's put in our permissives here. So what we want to do at the beginning is check our permissives and make sure that all of our valves and everything are in automatic mode. So we're going to call this one devices in automatic. And then all valves and pumps and other devices. So that's our description, and we're going to check that on our step 0. So before we move on, so we just want to make sure that we have those permissives there, that everything is in automatic before we start up. We could do a couple of other permissives, but I think that pretty much takes care of it. We could have a permissive like our glycol is good, or other things like that. One thing that I would add in to this one is when we use water, or if we use water, we're going to make sure that that gate switch is in the right position. But since we're not going that far with this particular functional description, we're just going to leave this as is. And then if you wanted to do an interlock of anything else, like if this pump was faulted, maybe that would be an interlock, put it all to 0. But we'll handle this for alarming positions later, because we don't necessarily want to shut down our entire system if that happens. One thing we will do, though, we will have e-stop is okay. So we check that during step 0. It's actually going to be checked all steps. And then if the interlock is not okay, then we are always going to move to step 0. So those are the interlocks and permissives. I guess we'll just move on to alarming here. So our alarm here is a high level alarm. So we got LSSP 0605. That'll be a disagree alarm. The disagree alarm is that it's going to be in a state that you don't want it to be in. And we'll get to that when we actually get into the code. So that means that the skim tank high level switch alarm, that's a digital alarm. And we can also do a LTSP 0607 high alarm. So that's skim tank high level alarm. That is also a digital alarm. Other alarms that can change the system state is going to be our PSP fault. So we have PSP 0140 fail alarm. That is pump fault. Digital alarm. And then what we want to do, we'll create a column here. I forgot to do that. Is what we do at the end. We got to add the check step. And then what's going to happen when that goes on. So I guess we'll call it consequence, for lack of better words. All right, we're going to check our high level switch alarm anytime we're getting a product into the system. So anytime that we could be adding into it, we want to make sure we're checking for that alarm. So that is going to be in steps when we're receiving product. So step 20 or 25. And our consequence is going to be unable to accept product. We're going to check our pump fault whenever we're sending product. So that'll be 15 or 25. Unable to send product. Suppose we could also look at digital alarms for the low levels too. So if we are of a low level switch, that means our tank is completely empty. So we're checking that in 15 and 25. And what our consequence is we're unable to send product. We're also checking this one, 15 and 25. And we may be able to send product. We may not be able to. So it's going to be a operation alarm where we're probably going to just stop sending product. All right, so now we've created our alarms. Now we're going to add our alarms into our flow diagram here. The way that I like to do that here is creating a transition and going to a different state. So I maximize this. This will make it a little easier to see. We'll create an alarm. I like to create it from a step start here. So this will be the high level switch or high alarm. Then we can make this color red so you can see it. So if we get an alarm and we're monitoring it, then we're going to have a condition that happens. Oops. We're going to check to see what step it is, and if it's step 20, or 25, we're monitoring that. Those are the steps that we're monitoring that. And if not, then we don't do anything. And if they are, then what we're going to do is we're going to transition to the step that we want. So if it's in step 20, we're going to transition to step 10. And if it's in step 25, we're going to transition to step 15. So step 20, we're going to transition to step 10. And then if it's in step 25, we're going to transition to step 15. This is when you have to try to clean it up. It gets a little bit confusing at here, so you have to work with the aesthetics of it. So no. And if it's neither one of those, then we don't manage that alarm. And then similarly, we would put one for the pump fault, the skim low tank or a low level. And we'll put those into that flow diagram as well. And I will put that in and we will move on to the next part. All right, so I cleaned it up here so that it makes some sense. So we've got our step 25, and if we are in step 25, we get our alarms either in the steps, then we move to the specific step that we have there. And that's how we're going to handle alarming. So it's just a matter of getting that in there so it looks reasonably good, I guess. This is going to be deliverable to the customer. And it's also easier to see it. We've got all of our alarms taken care of here. And then that is it for our functional description. Thank you.